I'm not going to do this right now. We'll do this in a couple slides. The point of it is that this section is about, it says multivariable linear systems. What it means is now we're going to solve systems that are bigger than 2 by 2. This is an example of a bigger system. It's 3 equations and 3 variables. So we learned some methods that we could learn for, bigger systems of equations. I mean, you could always use substitution. You could solve one of these, like I could solve this for x, and that would be 3y plus 4. And then I could plug in for x here and here, and I would have 2 equations with y and z. And then I could use substitution, elimination, whatever, right? In that way, you could deal with any dimensions of a system of equations, even 10 by 10. Solve one in terms of one variable and plug it into the other 9, right? Then solve one of those in terms of one variable and plug it into the other 8. And keep doing it until you get down to a 2 by 2, and then substitution, elimination, whatever. But that's not what we want to do. It is kind of what you do. And, years and years ago when I was first learning this stuff, that was kind of what you had to do. We don't have the methods that we have today, or that what you're going to learn today in class, that are kind of sitting right there in your hand. You could imagine what that is. So here's the first example. If I'm going to go into this process of solving by substitution, then if I have a system which looks like this, it's actually going to be pretty easy, right? Because one of them is already solved for one of the variables. The next equation only has that variable and one other, so we can plug in for that and solve. Y plus 3 times 2 equals 5. So y plus 6 equals 5. Y equals -1. And then, since we know y and z, we can go to the first equation, plug in for y and z, and we can solve for x. X minus 2 times -1 plus 3 times 2 equals 9. So x plus 2 plus 6 equals 9. X plus 8 equals 9. X equals 1. Right? This pattern of a system, when it's like that, that's called row echelon form. Row echelon. And if it's in that form, then we solve it by what we call back substitution, right? One of them is already solved, so just back substitute into the one that has 2 variables, and then back substitute into the one that has 3, right? Solve by back substitution.